Okay, so we're going to look at section 9.5, applications of interest and mixture. This is continuing the systems of equations problems, final section of this chapter. So it's just more application, and it's very similar to section 9.4. If you're kind of getting the hang of section 9.4, I think that you'll do fine with this section, just a little bit of variation, but you're still trying to come up with two equations that work for any given problem, and then try to work it out either with substitution or the addition method. This problem says Kevin has half of his investments in stock paying an 11% dividend and the other half in a debentured stock paying 12% interest. If his total annual interest is $690, how much does he have invested? So I think this would be a quick problem to solve, and I'm just going to kind of talk through this one quickly so we can get going with a number of these problems. If I were to take 0.11 x plus 0.12 y equals 690, I would have the first equation, which kind of gives me total interest. Now the second equation is going to be based on the relationship that he's putting half of his investment in each one. So really, if each one is half of the investment, x and y, the two dollar amounts that he's investing, are the same. So the other equation would be x equals y. So 0.11x plus 0.12y equals 690, and second equation, x equals y. With substitution, you'll be able to work it out, and you'll be able to find that you'll get something like 0.23x equals 690. You'll solve it quickly, and you'll get 3,000 for the first investment, which of course is the same for the second investment. So it's 3,000 in each, and then the total is just 3,000 plus 3,000, which is 6,000. Okay, another problem. A dairyman wants to mix a 70% protein supplement and a standard 10% protein ration to make 1,200 pounds of a high-grade 15% protein ration. How many pounds of each should he use? Okay, so we got to kind of think about how we're going to set this up. I believe what this is saying in terms of solving is we could have an x and a y, and each one of those are a certain amount of pounds that represent these different rates of protein in their content. Let's do the tutor mode for this one because it's kind of a new example for us. If they say x is the 70% protein supplement, y is the amount of 10% protein ration, I think what we could say is 0.7 x, 70% of x, plus 0.1 y, 10% of the y, is all kind of pure protein. And then that's going to equal pure protein that's in the total. It's a 15% of the 1,200. So what I could do with my calculator, I believe, is I could just say 15%, which is 0.15, times 1,200 should give me 180 pounds of pure protein in the total. Okay, so that's the first equation. The second equation, I believe, would just be saying that, hey, if I've got x pounds of one, which is protein and everything else that would be in there, just the total pound amount, and then the y, which is also pounds, that should equal 1,200 total pounds. So there's other stuff than just protein in that, but it's just x plus y equals 1,200. So we've got two equations there, and that might be kind of a new little step on this one, is that you had to figure out the pure protein poundage by doing the 1,200 times 15%. So a lot of these mixed type problems will have these two types of equations when you work them out. Gotta make sure I'm right before I get too confident. That looks good. And then they're trying to walk you through, I guess, by doing it through the addition method. Remember, you can also do the substitution method if it makes sense. But if we did the addition method, I could see, let's see, potentially multiplying everything on this line, let's say by negative 0.1 or negative 0.10. I'll say negative 0.1 because that's going to cancel with this column here with the y's if I do that. And then I don't need to make any change to the other one. If you couldn't just do that, have a common value, you'd have to come up with kind of like a lowest common denominator, or lowest common multiple, I should say, of sorts between the two by multiplying each of them by something other than 1 and create cancellation. But this will work just fine. So we get that. And then when I multiply by negative 0.1, they say what would we have? We'd have negative 0.1x minus 0.1y equals, if you take a tenth of 1200 and make it negative, you'd have a negative 120. And the other equation stays the same. Okay. And then add the columns up. Okay, well if I add these guys up, I'm going to get 0.6x. The y's cancel. And then I get equals. And then I get 60. So if I take 0.6x and I equals 60 and I divide by 0.6, I'm going to get, well think about it, if it were 6, it would go in and I'd get 10. But the decimal shift makes it so it goes in 10 more times by power, so we're talking about 100 for x. So divide both sides by 0.6 on that equation. Next, substitute x equals 100 into either of the two equations. I think I'd probably want to do the equation that was, did I list it there? Equation 1, equation 2. Let's see what they want. Okay, so they already set that up. You can plug it into either equation and work it out from there, but this one looks pretty slick because I can just say plug in 100, and then, of course, subtract 100 from both sides. Y would become 1100. So 1100 pounds, 10%, 100 pounds at the 70%. Would be correct. Alright, so really quickly, a total of 7,000 is invested, part at 6%, the remainder at 14%. How much is invested at each rate if the interest is 540 bucks? Okay, so if you do the two equations, it's very similar to the previous example. 0.06x plus 0.14y equals 540 would give you the respective interest values added up to give you the total interest of 540. The second equation would give you the amount that you invested in each type of investment. If I add those two up, I should get the 7,000 total. So those are the two equations, again, very similar to the previous example, except the 540 is already kind of given to us instead of needing to apply a rate to the 7,000 to get that number. So we're good there. And then they just want to know how to solve it out from here. I'm going to multiply everything by pretty much whatever's going to work here. I could do everything by negative 0.14 if I want to get rid of this guy. So we'll work that out. And multiply this by just 1. And then they want me to write it out. Okay, so I just typed them all out. Multiplied with the negative 0.14 factor on the top. Then I got to add the columns up. Negative 0.08x. Middle column cancels. That should equal negative 440. And then divide by negative 0.08. You should get 5,500 for x And when you plug that back into one of the equations, probably this one here is the easiest, you're going to get 1,500 for the Y value. So $5,500 for the first type of investment at 6%, $1,500 at 14%. I'm out of time, so I'll do another video